All right, hey everybody. So this is going to be a video on how to factor and how to solve quadratics by factoring, assuming that you can. It's not always possible, but it's maybe, when it is possible, it's maybe the simplest way of solving a quadratic. So the method that I use, that I think is most common, is a method for factoring a quadratic is called the AC method. And it's called that because it sort of relies on this sort of very clever way of breaking this up into pieces that can be further factored a little bit more easily. And the A and the C in particular come from the generic form of a quadratic is given this way: ax squared plus bx plus c. So what I'll do for the AC method is first I'm going to walk through an example because I think that it makes it a little bit more obvious, at least how to do the procedure, maybe not necessarily why it works, but how to do the procedure. And then after that I'll write the general procedure and we'll look at a couple of kind of examples where things can get a little bit tricky. So here's our quadratic: x squared plus 8x plus 15 equals 0. So what this is saying, if we want to solve this, then we're trying to find the x values that we can plug into here that will make this true, that will make the left-hand side equal to 0. So the AC method, it kind of starts like this. Pretty commonly, at least, this is how people will do it. You draw this little x. At the top, we're going to put the product of A and C. So, and A and C come from the generic form of a quadratic. A, regardless of the order that the quadratic is written, A is always the coefficient that is attached to x squared. So in this case, we just have x squared here. A, there's actually sort of like an invisible 1 in front of here. 1 times x squared is just x squared. So in this case, A is 1. B is always the piece that is attached to the x, just the singleton x. So in this case, B is 8. And then C is always the constant, the piece that doesn't have a variable at all. There's no x there. So C is 15. All right. And the way that we'll go about this is in the top here, I'm going to write the product of A times C. So A is 1, C is 15. 1 times 15 is 15. In the bottom of this grid, I just write B. Just write it there. You don't have to do anything at all. B is 8. Just put it there. So now what we're doing is we want to look for two numbers that multiply to make AC in the top. So two numbers that multiply to make 15, and those same two numbers that add to make 8, like this. So it may be obvious to you if it's not, and this takes practice. Like, it's not always the case that it might be obvious to you. Sometimes you have to do a little bit of digging, a little bit of thinking. The more that you do these, the faster that you'll find those two numbers. But if you have trouble finding the two numbers, here's what I suggest as sort of a systematic way of finding the two numbers that multiply to make AC, add to make 8. Write out all of the factors of AC. So factors mean two numbers that multiply together to make that number. So we're writing out all of the factors of 15. What are those factors? Well, 1 times 15 is 15, and there's not a lot of factors. 2 doesn't go into 15. 3 goes into 15. 3 times 5 is 15. And these are actually all of the factors because the next kind of factor that I would hit here is 5, so it'd be 5, 3, 15, 1. So these are just really all of the factors. And then I'm going to look at these pairs of factors and I'm going to add them together to see, do either of them do any of them sum to 8. So 1 plus 15, no, that's 16. 3 plus 5, yeah, that's 8. So, in other words, 3 times 5 is 15. 3 plus 5 is 8. So in my grid over here, I'm going to write those two numbers, 3 and 5. Now the next thing that I'll do, and there actually is sort of a shortcut, but I'm just going to like talk about like the full procedure, the general procedure that works no matter what. The next thing that we're going to do is we're going to rewrite our quadratic, but we're going to split up b according to these two pieces. So it's like this ax squared, that piece stays the same, just x squared plus, and now rather than writing 8x, I'm going to split that up as 3x and 5x, because 3x plus 5x is 8x. So I'll say this is x squared plus 3x plus 5x plus 15 equals 0. So I haven't changed my quadratic at all. It's the exact same thing. I've just rewritten this middle term. I've kind of split it up into two different pieces. Now that I've done this, kind of like expanded this out, what I'll do is I'm going to factor the first pair of terms. I'm going to factor the second pair of terms. So what can I factor out of x squared and 3x? The only common factor they share is x. So when I divide through by x, I would have x times x plus 3, right? If I distribute this x back in, then I get x squared plus 3x, which is exactly what I have written here. What can I factor out of 5x and 15 is 5. So plus 5 times x plus 3. If I distribute 5 back in, 5 times x is 5x, 5 times 3 is 15. And now, and this is the part that like maybe looks a little bit strange to a lot of people, notice that in the parentheses, these are like, they're matching. It's the exact same thing. So what I can do is I can factor that x plus 3 out. So this ends up being, and when I say that, kind of in practice, what that looks like is taking the coefficients of the x plus 3 and putting them together in parentheses. So x plus 5 in this first set of parentheses times x plus 3. One way to kind of think about this is that like I could think about like moving, if I was moving sort of upwards, taking this x plus 3 and distributing it, because this x plus 3 would get distributed to both the 5 and to the x. So that's how you get, when this x plus 3 gets distributed to x, that's how I end up with this term right here, x times x plus 3. When x plus 3 is distributed to the 5, that's where I get the 5 times x plus 3. So it's kind of like I'm actually just factoring that x plus 3 out. So now I have this these two binomials. It's been fully factored and it's set equal to 0. And here's kind of like the theoretical side of the next step, is that we're going to take advantage of something in our number system in our algebra called the zero product property, which just means that if you have some product of two numbers, if you have a times b and that product equals 0, this is true, or this can only happen if and only if a equals 0, b equals 0, or both. So kind of the higher algebra terminology that we would say is that our number system, the real numbers, they don't have 0 divisors. That if you have a product that equals 0, one of those numbers must be 0. So here we have a product that equals 0. This can only be the case if one or both of these binomials is equal to 0. So in practice, what that looks like in order to solve this thing out is I just break this up into two different equations. X plus 5 equals 0 and x plus 3 equals 0. And then I solve them for x. So x plus 5 equals 0. All right. X equals negative 5. X plus 3 equals 0. X equals negative 3. So those are the solutions, is x equals negative 5 or negative 3. And yeah, if you wanted to just double check, you could plug either of these back into the original equation, and it should come out to 0. So I'll just kind of do it in my head here with -3. If I plug -3 into here, well, -3 squared is 9. 8 times -3 is -24, so 9 minus 24 is -15. -15 plus 15 is 0. So yeah, it checks out. And if you want to double check it, you could plug in -5 in there as well. It's going to check out. And you might notice there is kind of like this shortcut that once you find these two numbers, the 3 and the 5, you can actually just jump straight to this factored step. But there's a caveat. This is only if a equals 1. So in this situation, like we said, a is equal to 1. When a is equal to 1, then when you find your two numbers, you can jump straight to the factored form. It tells you exactly what the factored form will be. X plus 5 times x plus 3. Only if a equals 1. If a is not 1, you can't do this. So let's look at an example. Let's look at an example where a is not 1. So we'll try this example. Where is it? 12x squared plus 11x plus 2 equals 0. So let's write out a, b, and c first. A is 12. It's always the piece that's attached to the x squared. B is 11, the piece that's attached to x. And then c is 2. All right, so now we'll do our AC method. So what do we fill up in the top? That's the product of A and C. A times C, 12 times 2 is 24. In the bottom is B, 11. So we need two numbers that multiply to make 24, but add to make 11. Again, if you don't see it immediately, one way of doing it, one way of finding this, sort of a systematic way, is by listing out all of the factors of AC. So 24 has factors 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then we just look through these rows, add them across to see which ones equal 11. So 1 plus 24, no. 2 plus 12, no. 3 plus 8, yeah. So 3 and 8. 3 times 8 is 24. 3 plus 8 is 11. But this is a case where a is not equal to 1. So we can't just jump straight to this factored form. We have to do this, these intermediary steps. So let's do that. Well, I'll rewrite my quadratic, 12x squared plus, let's see, and I want to do it in a specific order because one of the orders is a little bit more confusing, and I'll show you that one too, but just to make it a little bit clearer up front. Yeah. So I'm just rewriting my middle term, 11x, according to the two pieces that I just found. 3x plus 8x is 11x. So I haven't changed anything, I've just rewritten the middle term. Now I'm going to factor the pairs of terms. So, right, what can I pull out of 12x squared? Well, I can pull 3x out of there. 12x squared and 3x, I can pull 3x out. 12x squared divided by 3x is 4x. 3x divided by 3x is 1. And at this step, it's always smart to just do a quick double check. If I distribute 3x back in, 3x times 4x, 12x squared. 3x times 1, 3x. What can I factor out of 8x and 2? Well, just 2. So 2, 8x divided by 2 is 4x. 2 divided by 2 is 1. And there we have our matching pieces inside of the parentheses, which means the other sort of factor, the other binomial, is the coefficients sort of put together into parentheses. So this is going to factor to 3x plus 2 times 4x plus 1. So see how we can't just jump straight from having these two numbers to the factored form. That the 3 and the 8 aren't actually like showing up in here. at least not directly. So you do have to do this middle step. But from here, it's the exact same thing. We'll set 3x plus 2 equal to 0, which gives us x equals negative 2/3. We set 4x plus 1 equal to 0, which gives us x equals negative 1/4. And those are the solutions to this. You can feel free, if you like, it's going to be a little bit uglier, but you can feel free to plug these back into the original equation and it's going to check out. Right, so the next thing that I want to do, and I won't do it on the back of this paper, I want to kind of keep that on the screen if possible. It looks a little strange. Okay, so I mentioned though that like you like on let's see, what step was it? This step right here, I said, oh, I need to do this in a specific order. You can do it in this other order. So if you got here, you found your 3 and your 8, and if you rewrote the quadratic in this way, 12x squared plus 8x plus 3x plus 2 equals 0. So it's the exact same thing. I just have flip-flopped the 3x and the 8x. If you write it this way, yeah, this works as well too. But watch what happens, because there's kind of this little trick that makes it look a little bit funky. So same thing, I need to factor the first and the second pairs. What can I factor out of 12x squared and 8x? I can factor 4x out of that. So it becomes 4x times 3x plus 2 plus, and now look, what can I factor out of 3x plus 2? Nothing. Nothing factors out of those. They don't have a common factor. So this just stays as 3x plus 2. So now I've got my matching pieces in the parentheses, which is a good sign. But what are my coefficients? Here, that one is 4x. What's the coefficient on 3x plus 2? There's actually this invisible 1 right there. 1 times 3x plus 2 is just 3x plus 2. So even though it's not written there, there is that 1 there, which means that this factors again to 4x plus 1 times 3x plus 2. Which is exactly what we have here. It's just flip-flopped, which is fine because multiplication is commutative. They're the exact same expression. They solve to the exact same thing. So be aware of that. The other thing that sometimes comes up is when you have to factor out a negative. So we'll do just one really quick example, and it'll be an example where a is 1. X squared minus 4x minus 21 equals 0. So again, AC method, two numbers that multiply to make negative 21, because 1 times negative 21 is negative 21. So notice here that this negative factors in. So I guess I should have written this just for completeness. A is still 1. B is not positive 4. B is negative 4. Let's see if I can focus this a little more. It looks a little blurry. So B is negative 4. Same thing with C. C is negative 21. So be careful about that. Make sure that you're paying attention to the sign before A, B, and C, because that changes things. So A is 1, C is negative 21. 1 times negative 21 is negative 21. B is negative 4. Two numbers that multiply to make negative 21, add to make negative 4. Well, the factors of 21, the non-trivial factors of 21 would be 3 and 7. Can I combine those somehow where one is negative and one is positive? And that's one thing to be thinking about here too, is that if AC is negative, that means that one of these two numbers that I find, one will be positive and one will be negative, because that's the only way, like positive times negative is the only way that a product becomes negative. Positive times positive is positive, negative times negative is also positive. So if AC is negative, one of these is positive, one is negative. The magic numbers are going to be negative 7 and 3. Negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. Since A is 1 here, then, right, I guess I can actually I could just jump, I could use my special little shortcut, but I'm actually going to not do that. Just to kind of show what happens when we have these negatives in here. So I'll say this is x squared minus 7x plus 3x minus 21. So same thing, negative 7x plus 3x is 4x. Sorry, actually, to show what I'm trying to show, I need to do it the other way. There's just this little thing that sometimes happens that is confusing for people. Let me write it this way. Again, it's the same thing. X squared plus 3x minus 7x. Here we go. Minus 21. Okay, same thing. All right, so same idea. What do I factor out of x squared plus 3x? Just an x. What can I factor out of, and this is where you need to be careful, because I'm not factoring things out of 7x minus 21. I'm asking myself, what can I factor out of negative 7x minus 21? And what I can factor out is, if you can factor out a negative, you should. So from both of these, I can factor out negative 7. So there will be a minus 7 here. And then what happens on the inside? Well, negative 7x divided by negative 7 becomes positive x. Negative 21 divided by negative 7 becomes positive 3. And that's the big mistake that a lot of people will make, is that they'll get to this step and they think to themselves, oh, I can factor out a 7. And then they do this part right. They technically factor out negative 7, and they say, okay, it's going to be minus 7 times x, but then they leave this as x minus 3 because they're not dividing the negative out of negative 21. But you are. You're dividing negative 7 out of this whole thing. So this becomes x minus 7 times x plus 3 equals 0. So yeah, and again, since a was 1, we could have just jumped straight to this step, but I wanted to show this business right here, that you've got to factor out the full negative from both pieces. Otherwise, you're not going to get the matching pieces in the parentheses. And then from here, you just solve it as normal. So x is 7 and x is negative 3. Okay, so that is how to factor and also how to solve quadratics by factoring. If you've got any questions, let me know.